Hi there and hello. Let's talk about network diagrams and specifically how to solve them in Excel, both with worksheet functions and with VBA, that's Visual Basic Applications, the programming language of Excel. But before I do that, I want to recap the theory just to make sure that we are on the same page. If you don't feel like you want to listen to theory, you can skip ahead to this time. Theory. Okay, so network diagram is a project management technique used for scheduling. So a project is any task, activity, or endeavor that has three primary characteristics. It is temporary, it is unique, somehow at least, and it has progressive elaboration. So a project is successful if we're able to bring about the project deliverables within the three fundamental constraints of time, cost, and scope. And making sure that we deliver on time, to do that we use scheduling techniques. So scheduling can be defined as this. There are different scheduling techniques that you could use. The simplest would be like just a milestone plan. Gantt chart is not one, but in this video we are just going to talk about network diagrams. However, if you know how to make a network diagram, you have the information necessary to create a Gantt chart, or they're kind of overlapping. So if you're going to make a network diagram, there are three things that you need to know. You need to have a list of the different activities that's going to constitute the network diagram. And the way to find that is usually to apply the work breakdown structure. By developing a work breakdown structure, you elucidate the different activities. That's going to make up for the network diagram. You also need to know the expected duration of each of these activities. There are many ways to do that. Here are a few different ways suggested by Gardner 2005, which provide us the definition of scheduling. And finally, you need to know the dependency between each of the activities. And to find that, you usually just apply your common sense. Activities are either dependent or they are independent. If the activities are independent, you can put them in parallel, like this. But if they are independent, then you need to put them in a sequence, which could look like this. However, there are four different types of dependencies, so there are different ways to put them in a sequence. So these four different sequences are finish to start, start to start, finish to finish, and start to finish. Unless stated otherwise, you are pretty much always dealing with the finish to start type of relationship, which means that activity A needs to finish before activity B can start. It is also important to know the difference between predecessor and the immediate predecessor, and the successor and the immediate successor. So as you can see here, we have a very simple network diagram that only shows the activity names. So if you look from the perspective of Charlie, everything that comes before are predecessor, but only the immediate predecessor, well, that's the immediate predecessor. Likewise, only the nodes that come immediately after Charlie are the immediate successors. You can obviously, of course, have more than just one immediate successor or predecessor. So all of that background information will culminate in this one single figure. So each of the nodes should consist of 3 rows and 3 columns. In the top left corner we have the EST, that's the earliest start time. Then we have the duration, which is in the top row, middle column. And then in the top row, final column, we have EFT, or the earliest finishing time. In the second row we have the activity name and or the activity code. And on the bottom row, going from left to right, we have LST, that's the latest starting time. We have the float, and we have the LFT, which is the latest finishing time. So to make a network diagram, we need to put up all the activities, put them in a proper sequence, and fill out this information: EST, duration, EFT, LST, float, and LFT. And as you can see here is the entire explanation for how you calculate that. So I recommend you just pause the video, you take a print screen of this, and then you keep this next to you while we go through the example. Example. Now that we know the theory, we can look at a very simple example. So in the example I've chosen here, there's only 8 different activities. As you can see here, it's a list of activities. We have activity A, which is initiation. We have B, which is engineering and platform. C, engineering pipeline. Jacket deck, building the pipeline, tie-in and completion. So that's the list of activities. But remember, there are two more required inputs in order to make the network diagram. Number one, we need the list of activities, but we also need to know the duration of each of these activities, and we also need to know the dependency between them. So one way to specify the dependency is just to list up all the immediate predecessors for any given activities. That is actually sufficient in order to create the network diagram. Based on the dependency table, we can make the basic structure of the network diagram, which I have done here. So just take a look at the dependency table, look at the immediate predecessors, and see that it is consistent with what I've drawn here. So for instance, it will say that the immediate predecessor of B and C is activity A. And that is exactly what I have done here. However, there are alternative ways to draw this. Activity D and E here could be switched around and will still be the same network diagram. So that's kind of potato. You can also take this whole branch here with activity B, D, E, and G and put it below the path here with C and F. So you can switch it a little bit around, but it's still fundamentally the same network diagram. But this is going to be the basic structure that we're going to work with. So the next stage here is to substitute these simple nodes, which have only the activity code, so activity name. I'm going to change it out with the more standard labeling, which has these 3 different rows and 3 different columns. So top left corner, we're going to have the earliest starting time. Then we're going to have here the duration in the top row in the middle column. And then in the top row in the final column, all the way to the right, we're going to have the the earliest finishing time. So the earliest starting time, duration, earliest finishing time. On the bottom here, you're going to have, going from left to right, you're going to have the latest starting time, the float, and the latest finishing time. So the first thing I'm going to do here is to substitute in these different durations, which is exogenous, which we are just given as like our input information. So here. So for instance, activity E for echo has 24 as its duration, 24 months I think is in this example. So next time we're going to do a forward pass where we're going to populate the top row here with the information, the earliest and earliest finishing time and earliest starting time. So we're going to start all the way from left there and move slowly to the right. So by definition, the earliest starting time for the first activity is always going to be equal to 0. So that's just 0. And the earliest finishing time, that's always going to be equal to the sum of the two numbers to the left there. So the earliest starting time, 0, plus the duration, 2, is going to be equal to the earliest finishing time of 2. Next here, we're going to look at the immediate successors there, B and C. Now B and C have only one immediate predecessor, namely activity A. So the earliest finishing time from A, which is 2, is going to be copy-pasted over here and become the earliest starting time for both B and C. So these two here, top right corner, becomes the top left corner for B and C. And then 2 plus 12 here is 14, and 2 plus 9 is 11. So we're going to move on here to activity D, E, and F. It's going to be the same story here really. For C, again, F has only one immediate predecessor, activity C. So we copy paste the top right corner here, the earliest finishing time, to become the top left corner of F, which is the earliest starting time. And 11 plus 12 is going to be equal to the earliest finishing time, which is 23. Up here with D and E is the same story. Both of them have only one immediate predecessor, namely B. So this 14 here gets copy pasted over. And 14 plus duration of 16, that yields an earliest finishing time here of 30 for activity D. And similarly here for activity E, 14 plus 24 is 38. Next here, we're not going to do H just yet, because we need to figure out G first. So we cannot figure out any activity here before we have all of the immediate predecessors. So we're going to start here with G. And G now here is a bit different situation. So far, every single activity had only one immediate predecessor, but G here has two immediate predecessors. So what do you do then? Well, you're still gonna look at the earliest finishing time, the top right corner of the predecessors, plural, but you can only choose one number, and the number you pick is gonna be the highest one. So the highest, earliest finishing time among all of the immediate predecessors. So either 30 from D or 38 from E. Well, 38 is greater than 30, so we copy paste 38 over. And the earliest starting time here of 38 plus the duration of 2, well, that's going to be equal to an earliest finishing time of 40. So now that we know G and F, we can finally do activity H. So again, here there are two immediate predecessors from H, that's G and F. G has a higher earliest finishing time of 40, that's greater than 23 from F, so we copy paste 40 over. 40 plus 1 equals 41. And that's the end of the forward pass. So the final number here, this is going to be the duration of the entire project. This project is going to have a duration of 41 months, assuming you have enough person power to actually do all of these activities simultaneously when they are in parallel. So next here we need to do the backward pass. So that's about populating the bottom row here. So the latest finishing time, that the bottom right corner here, is always going to be equal to the earliest finishing time for the final activity. So for final activity, we just take the top right corner and copy paste it down to the bottom right corner. As easy as that. It's going to be different for the other activities though, but this is a special rule only for the final activity. So we have a special rule here for the top left corner, the earliest starting time for the initial activity, just equal to 0. And then we have a special rule here for the latest finishing time of the final activity. So that's something you need to keep in mind. The number here in the middle on the bottom row, that's the float. That is how many units of time that particular activity can be delayed without delaying the entire project. And that is going to be equal to the latest finishing time, the bottom right corner, minus the top right corner, which is the earliest finishing time. So 41 minus 41 equals 0. Now there's an alternative equation here, and that is to look at the bottom left corner and the bottom and the top left corner. So the latest starting time 40 minus the earliest starting time 40, well, that's also equal to 0. So it doesn't matter which one you use, it's going to be the same. I prefer to use the finishing times though. So to find this bottom left corner, that's the latest starting time, you just take the latest finishing time, which in this case is 41, and you subtract the duration of 1, which is 40. Then we can move on there to activity G and F. So both G and F has only one immediate successor. G has only one immediate successor, and that is H. So we're going to copy paste the latest starting time, the bottom left corner of H, to become the bottom right corner here of G. So 40, copy paste over. It's the same story here with F. So for G here, the float is going to be 40 minus 40, and the latest starting time, 38, well, that's just 40 minus 2. Same with F, 40 minus 23, that's going to be 17, and the latest starting time, 28, so that's 40 minus 12. So when the float is 0, that means that you cannot delay the activity without delaying the entire project. So any single activity that has a float of 0, that's on the critical path. Activity F here has a non-zero, has a positive number for float, so this means that this can actually be delayed for quite a while without it impacting the total duration of the project. So you can delay it with as much as 17 time periods here before it becomes a problem. So that's something to keep in mind. Let's move on here to look at D, E, and C. Again, D and E has only one immediate successor, G, so we copy paste the bottom left corner, 38, to become the bottom right corner here of D and E. And the float for D is just 38 minus 30, and the latest starting time, 22, 38 minus 16. Same story here for activity E, and same story for C, except here the immediate successor is F. So we take this 28 and put it over. 28 minus 11, that's 17, and 28 minus 9, well, that's 19. Now here we need to look at B. We cannot look at A yet because we need to figure out B first. We need to figure out all the immediate successors before you can look at the particular activity. And for B, we now have a situation here that there is not just one single immediate successor. There are two. So what do you do then? Well, when we did the forward pass, we took the maximum number. This time we're going to take the minimum number. So the latest finishing time of activity B is going to be the lowest latest starting time among all of its immediate successors. So we're going to compare 22 to 14. Well, 14 is less than 22. So 14, the latest starting time of activity E, is going to become the latest finishing time of activity B. The smallest number we copy paste over. And then again, float 0, that's 14 minus 14. Latest starting time 2, 14 minus 12. So for the final activity here, we again have two immediate successors. So we need to look at the latest starting times from all of the immediate successors. That's either 2 or 19. Well, 2 is less, so we go for 2. And that's basically it. That's the entire network diagram. So it's pretty straightforward, but there were quite a few things to keep track of here. But it is perfectly algorithmic, so it is straightforward. You just practice a few times and you got it. But this is extremely tedious to do this way, so we should, or we can do this in more dedicated software, but I'm going to show how to do that in Excel. But just for pedagogical reasons, I recommend that you try to solve this small network diagrams examples with pen and paper, like manually, like we just did here, so you get it, so you can learn it properly. And once you have a firm grasp of it, then you can try to use more automatic approaches. So let's jump over to Excel. Excel. And here we are in Excel. I basically have two different ways of doing it. One is the slow and tedious way that I don't recommend if you just want to make the network diagram and be done with it. But this is probably the best way to learn about how the network diagram works and functions. So it's basically exactly the same as you already did. You just put it up like this. So what I did, I just create like a node like this. We make it yellow, and we can, let's see, we can make some borders like that, and we can merge it, and then you write the name here. So what I do, I use VLOOKUP, look up for the name, from the table over here, like this, and then let's see number 2, and it needs to be an exact match like that. So you can automatically get the duration. And the earliest finishing time, you can hard code this. This is also going to be the same. So the sum of these two. You can also do the same with the float. The float is always just this minus this one over there. And the latest starting time is the latest finishing time minus the duration. So you can just do like this and then just copy paste it as I already done here. The only thing you need to change would be the name, and we'll automatically give you the new duration, and you would have to kind of go in there and manually put some more effort into specifying the top left corner and the bottom right corner. So that's just how you can do it, and these arrows are just put in there. So very tedious, inefficient way of doing it, but this is for pedagogical reasons. So here is your 0, this one over there, as you can see, it is pretty straightforward. So this is what you can do. But the more efficient way would be to put it up like a table, which I've done over here. So we have two tables with input information. We have the list of activities here with their duration, and we have for each activity we have their immediate predecessors. So you can do this different ways. So I'm going to show a few different ways how to do it here. I'm going to increase in sophistication as we move downward. So ultimately I want to make a VBA script that can automatically calculate the EST and the LFT. So duration here, again, I just use VLOOKUP. So that's like a nice way to do it. So VLOOKUP, search for this activity from this table, and I want the second column, and I want an exact match, so the last parameter is just false. The earliest finishing time, that's just the sum of EST and duration, so you don't need to do much magic here, that's pretty easy. The latest starting time, that's just the latest finishing time minus duration. So again, this is a simple function, subtraction. Float, LFT minus LST, pretty straightforward. So the effort you need to put in here is again going to be EST and LFT. So here I've done it manually. So the first one, you're going to hardcode that, is always just going to be 0. Nothing needs to be, don't need to think about it, that's just by definition 0. LFT for the final activity H, and that's always just going to be equal to the earliest finishing time. So these are hard-coded, the rest you need to think about. So for B, for instance, what is the approach here? How do I think? Well, I think about, okay, I can look from the table here and see that B has only one immediate predecessor, and that is A. So I'm going to go up at A here and find its EFT, right? Same for C, that's again going to be A. For D and E, however, it's B, that's an immediate predecessor. For F, it's going to be C, and so on and so forth. So I'm just sitting here, and based on this table, I'm just looking up the value. So this is a very manual approach. So you need to do this for every single activity. And exactly the same thing here in terms of the LFT. I'm just looking up. And when there's more than one, well, then you take the minimum for LFT and the maximum for EST. So I'm doing it manually exactly the same way I did in the example. So can we do this more automatically? Yes, we can. So I'm going to look here at an example here with B. And what I'm going to do, I'm going to combine index match together with VLOOKUP. And the final product is going to look like this. So just combining these searching functions, I can use that to find automatically, what is the EFT. So the first thing we need to do, we need to know who is the immediate predecessor. So we're going to look for activity B here, and we want to know who is the immediate predecessor. Impred is short for immediate predecessor. So who is the immediate predecessor for activity B? I can use VLOOKUP for that. So VLOOKUP, who am I searching for? I'm going to search for B, so I'll click there. And where am I searching from? Well, that's over here, right? I can lock it like that. And I want to have first, second column, the second column. So this approach here is going to work only if there's just one immediate predecessor. If there's two immediate predecessors, we're going to have to take the function we're going to make here and do it twice, and then wrap that in or put that inside of a max function. But more on that later. And I want an exact match. So hopefully this will tell us, hey, the immediate predecessor B is A. And there it is. Then we need to figure out what exactly is the EFT for activity A. So the EFT of activity A, what's that going to be? Well, we're going to use index match combination. So index, what do I want? I want the EFT. How do I know which EFT that I want? Well, to do that, or figure out that, I'm going to use the match function. I'm going to be looking for the immediate predecessor, which is over there, that's A. And where am I looking from? Well, that's over here, right? I'm going to lock that. And then we can specify exact match, double end parenthesis. And that's going to be 2. So that worked. So here we have the VLOOKUP, and here we have this index match. And I'm referring here to the VLOOKUP over there. So that's what's going on here. I just combine this inside of each other. That's the logic here. So this is how you can find the immediate predecessor. So for the first activity, by definition, that's 0. So I didn't use the function there. Here we have this combination of VLOOKUP and index match. And I'm just doing that again and again and again until I get to G and H. And here, something happened. Well, here I have done this approach twice. So let's see, here it is, one time, and then another time. and it's inside of this max function that starts here and ends there. So I'm just doing it twice. And the only difference is that I changed the column I'm looking at in the VLOOKUP. So first look at number 2, so over here. And then I look at number 3, which is here. So if I had 3 immediate predecessor, I need to do it 3 times. And if I have 4, I need to do it 4 times. So there is some limitations here with doing it with worksheet functions. So what I want to do is to recreate this approach in VBA, Visual Basic Applications, the programming language of Excel. And I want to also use a for loop, so I can loop through each of the different immediate predecessors. And also want like an if then else function that can say, okay, well, if it is the first activity, well, then it's equal to 0. So I'm going to open up VBA here with Alt F11. There it is. I'm just going to make it a bit smaller. So here I made a function, a VBA function. So I write function and then the name of the function, and I came up with this long name, network diagram _ forward pass _ EST. And it has a bunch of different inputs here, as you can see. I want to know which activity I'm looking at. I need the dependency table. I need a list of the predecessor list. I need the EFT, and I need the activity list. So what's going on here? Let's see. In the core here, these 3 lines here, this is recreating what we did in the worksheet with the VLOOKUP and the index match. So first here, let's see, it is, you can see the whole thing. Let me just make that a little bit bigger. So here we are recreating the VLOOKUP to find the immediate predecessor. So application.worksheet function, that is to enables you to use the worksheet function using the VLOOKUP, and then I just use the inputs that are defined up here. Then I do the index matching. It became such a long line as I split it into 2. So first I do the match, and then I do the index. And then this is wrapped inside of a for loop, so I'm looping through each of the immediate predecessors, and I'm selecting the one that has the highest value. So that's what's going on here, selecting the highest value. And then all of this is wrapped inside of a if then else statement. So if the number of predecessors is equal to 0, well, that would mean that you are in the initial activity. And if that's the case, well, then you're just hard coding and saying that, well, the early starting time is just going to be equal to 0. But if it isn't the first activity, then you do this whole other shebang. So we can go back here to the worksheet and see it implemented down here. Here it is, network diagram, forward pass, EST, and then boop, 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 all the inputs there. So we can try and do it just one more time here. Let's see, can this over here. So network diagram EST, and now we have a problem. Okay, I don't remember, like it doesn't give an explanation here, which functions usually do. So you have to remember them. No, you don't. You can click Control, Shift, and A, and then it will show you the different inputs there. So the input here, let's see, I need some more space though, because I want to be able to see what's going on there. So let's see, let's try over here. Network diagram, EST, Control, Shift, A. First we need the activity. Well, for activity B, then I need a dependency table. Well, that's over here, right? That's the dependency table. Lock that. Then we need the predecessor list. What is that? Well, for activity B, that would be these 2. All right, these 2. Then I need the EFT. Oh, that's over there. Can lock it. And we need the activity list. Well, that is over there. I'm gonna lock that too. Click enter, and so see it's 2. And then there's 0. And you see, you're getting the same list. So that is what's going on over here. So that I think that's an improvement. Although this script looks like a mess. So, but I'm gonna put the script out on my course page so you can see there, so you don't have to transcribe it. So that is that's the EST. Now when it comes to the LFT, it is actually a lot more difficult because you need to do it backwards. If I want to know the immediate predecessor of activity B, for instance, I can just look up this table and say, okay, it's A. But how do I know the immediate successors for activity A, for instance? Well, I will have to look at this list here and figure out, okay, here's A, and over there is B, here's A again, so that's over C. So you kind of need to do the whole thing in reverse. And I'm just not sufficiently good at VBA programming because I have absolutely no qualification in VBA. So I didn't find a nice way to do it. So I have to take an intermediate step here. There's a neighbor driving by out in the street. So I made an intermediate step. So I made a function that is creating based on the immediate predecessor dependency table. It will recreate this table, but instead give you the immediate successor. You see? So this table in reverse. So here the immediate predecessor of B is A. So then the immediate successor of A will be B and C. Because you see AA and BC. And then I can just use basically the same script I used for the EST, except instead of taking the highest value, I take the lowest value. And if it's the final activity, then it takes the earliest finishing time for that activity. So how did I make this table? I can show you. So Alt F11 to open up. So it is over here. So I made a function called immediate successors. So you need the activity list, and then the immediate predecessors, and that's it. So I have a snippet of code here, which I didn't figure out how to make on my own. So I used the power of DuckDuckGo, and here's the URL address. So I found a snippet of code there that I just stole, and now I'm just using that. So this script here, I don't want to go into the details here. If you find this sort of things interesting, you can take a look at this. I'm just going to slowly scroll through here. So the logic here is not that difficult. It's just a bit tedious. If you're not a programmer, if you have zero experience with programming, then this might seem intimidating, but it is a pretty straightforward thing, really. So the basic idea here is that I'm taking this table and changing it from finding the immediate predecessor to be the immediate successor instead. So kind of turning around the information so that it becomes wobbly. So here it is. This is just one big array. So immediate successor, I specify the activity list and the predecessor list, and it gives me this table, right? So this nice table. So to find the LFT here, I made a function called network diagram backward past LFT, and it has this these different inputs. So I can show the script for that, and that is over here. So it's basically the same thing. We have almost the same inputs. It is counting how many successors there are. If the number of successors is 0, well, then you are looking at the final activity. And if that's the case, well, then the latest starting time is just going to be equal to the earliest finishing time of the same activity, right? If that's not the case, then you use VLOOKUP, and you use match, and you use the index to kind of find the value for you. And then selecting the maximum value, you select the minimum value. And that's basically it, pretty straightforward. So we can try to recreate that function. Let's see what's going on there. I have an invisible box over there. So let's see. Over here equals network diagram, the latest finishing time, Control-Shift-A. So we need the activity. The activity is A. Dependency table. Well, we need the immediate successor dependency table, not the immediate predecessor as we did before. Let's see, and that we need to lock. We need to lock it. Then we need the list of successors for activity A. Well, that is going to be these two guys. We don't need to lock that. And we need the latest starting time. That's over here. That we should lock. And we need the activity list. That's over there. And we need the earliest finishing time, which is over here, like that. So I feel like I did a mistake here, but no, it seemed to work. Oh, good. So then you can just copy paste this, you know, downwards. Oops. And it just works. So that's nice. So this is a way you can do it. Let me just show you one more time the scripts. We have the script for the earliest starting time. And we have the script for the earliest finishing time. But it requires, let's see if you can see the whole script there. There, no, you see the whole script. But it requires that the dependency table is specified in terms of who is the immediate successor. And to do that, I have this over here, which I guess you don't see the whole thing, but so that's nice. So that's how we do it. Thanks for watching.